Welcome to our project presentation titled Term Deposit Subscription and Analysis. This project is being developed by Samson Akomolafe, myself, and my teammate, Ecom Brower. Our project objective is divided into three different objectives. First, we want to determine key factors that influences customer decision to subscribe to this term deposit. And second, we want to build different competing statistical methods to see the relationship between the different factors about each customer, the relationship that will have on their subscription. And then the third one is to predict a term deposit subscription projection using our model's outcome, and ultimately to recommend the best performing model for practical implementation. Now I'll call on Ecom to continue the presentation.
All right, thank you, Samson, for the introduction. So in this data, we got it from the UCI Machine Learning Repository. This is data from the marketing efforts of a Portuguese bank. So you have all 45,000 data points, 17 columns and features, and all sorts of attributes about the customers they reached out to, the outcome, the previous outcome, their jobs, their marital status, etc., education, all the good stuff that we can use, incorporate into our model, and have some great predictive power. The response variable has a binary classification. It's either no or yes. It's a ratio of 75% for no and 25% for the yes classes, respectfully. And so we put it into our pipeline. And in our pipeline of data processing, the response variable is named Y, it's coded as Y, and we renamed it to subscribed. The unknown values were filtered out because can't really get a lot of data with unknown. And then the data was split into training, 80%, and testing, 20%, different sets. Training set has 6,274 observations, while the test set had 1,568 observations. So let's move on to our exploratory data analysis, or EDA. The first thing we looked at here was the distribution of our response variable in the training data. As you can see in this bar chart, the classes are imbalanced. We have 4,845 no's, 1,429 yeses. Which is about a split of 77 and 28. This imbalance is really significant because if we were going to build a lazy model that only predicted no every single time, that would be 77% accurate. And that's a high accuracy figure, but it would be really misleading. So we can't just rely on accuracy. We're going to need to focus on more nuanced metrics like sensitivity, specificity, and we'll talk about that more later, but we want to really understand our model's performance. And with a data set like this, just relying on accuracy would be misleading. So let's explore some of our visualizations here. As part of our EDA process, we explored how a customer's job and their education level relate to their likelihood of subscribing. This chart shows the subscription rate broken down by both categories. We can see some clear trends here. We can see that individuals who are retired or students have the highest subscription rates. In contrast, we can notice that the blue-collar workers and our entrepreneurs have some of the lowest subscription rates. This gives us a pretty early indication that a lot of these demographic factors are going to be important predictors in our model. Our previous outcome campaign, the outcomes of our previous marketing campaign are illustrated here. This chart shows the subscription rate based off of those outcomes. We can see very clearly that the subscription rate for customers who had a success in a previous campaign is much higher. It's about 12% overall in terms of the customers that were captured in a previous marketing campaign. And it's distinctively higher than the ones whose outcome was a failure or other. And so probably understandably, the ones that subscribed in a previous campaign are far more likely to subscribe again because they were convinced the other time, they invested, probably like it. And so it's much easier to convert them. This variable is a very strong predictor as illustrated by this chart, and we're going to see it come up again and again in our modeling efforts. Now moving to the duration of the call, colored here by subscription status, we can see all the different density plots, and they show whether or not a customer ended up subscribing or not. So here, on the left, we notice that the distribution is heavily skewed to the right. The tails roll thin, and most of the calls are really short, under 250, 500 seconds. It's important to note that duration's measured after the contact begins, so it's better for changing your strategy in real time than it does, and it doesn't illustrate how you can target people before you contact them. But moving to the right, we can see that for customers who did subscribe, there's still a lot of short calls here, but the distribution has a longer tail and it's fatter. This shows that longer conversations are more frequently associated with a yes outcome. The longer the call, the more likely a subscription. And this confirms that duration is another potentially strong predictor. Marital status, we also see a noticeably higher rate in subscription for married people. It's potentially important, and it's a possible value that could play a big role here. Just another demographic consideration that could be useful in our modeling. And we'll kick it back to Samson.
Thank you, Ken. In continuation of EDA analysis, here we want to look at the duration of call by age. The Lewis plot here, scatter plot here, shows that those that subscribe to subscription, the yeses class is on top. They listen for longer period, and those that did not, they did not listen for a longer period. And we can see that this cut across all age group from age 20 to age about 90. And so from here, we can see that those that are between the ages of 30 and 60 is well clustered right there. The lowest yes score is consistent with higher than the no. If you look at it very well, is trending upwards within this age. And the subscriber that says no, they have shorter or more variable call duration. As you can see, is the red color is thick down there across all ages. It's possibly indicating less consistent interaction or quicker disengagement. But it's interesting to know that those that are between the ages of 70, from 70 to about 90 or 85 to 90, in both groups of yes and no, they kind of have a larger confidence interval based on the lowest score. So it shows that regardless of whether they are going to subscribe or not, it reflects that they spend more time listening to calls when we make call on them. And so this is also trying to look at comparing previous outcome, the previous campaign outcome with call duration. It shows that those that listen for longer period, about 1200 seconds, they actually are in the yes category. And those that did not subscribe in the failure in the previous campaign outcome, the failure group, if you look at the failure scatter plot there, right there, towards the end of it, the base of it is red. It shows that those that did not subscribe, they did not listen in long enough. And if you look at it, it's spotted across that one. But it clearly shows that those that that we were successful in our previous outcome, they kind of listen more up to 1200 seconds. So like my teammate have said, we want to look at duration in our modeling, and we also want to look at this previous campaign outcome. Both of these will play a good role in our model going forward. And so we are still looking at the impact of job occupation on call duration. We see here that students and retired people listen more if you look at what this is showing us. But blue-collar job people and those in service work, they really do not have time because they are career people. If you cannot present with them within 1 minute or 2 minutes, they don't have time to waste. So no wonder the subscription in this class is no. But relatively, we want to look at management and technician people too, because they are, kind of, showing a little promise there. But look at the age range. So it shows that students especially will listen, especially those in tertiary education, those are in the university, going through, the education we give us a little time to talk. They can listen because that's what the data is telling us. And then going forward, we're going to see more the EDA analysis.
All right, now we get to our first objective here, which is building an interpretable logistic regression model. Our goal here wasn't just prediction. We want to create a model that helps us understand the influence of each specific factor. And interpretability matters a lot here. And in our approach, we use a simple additive logistic regression model. We created this using all the predictors that we selected based off of the EDA that we just discussed, sort of common sense and consideration specific to this domain, which is bank and bank data, marketing, the term deposit. And in the R results here from our output, you can see what we got. So we want to interpret these coefficients to really understand their practical impact. So if we look at, we'll look at two predictors, duration and housing yes, which means that yes, they have a housing loan previously. So for duration, the coefficient is 0.00346. And if we want to interpret this, we're going to exponentiate it to get the odds ratio. That's about 1.0035. That means that for each additional second of the call duration, the odds of a customer subscribing increase by 0.35%, holding all the other factors constant. And that might seem small, but if you're talking on the phone for 5 minutes, 10 minutes, those all that 0.35% per second adds up really quickly. And that's statistically significant because the p-value is near zero, and it's practically significant. For housing yes, which means, again, that the customer has a housing loan, the coefficient is negative 1.02. And then the odds ratio is about 0.36. That means that the odds of subscribing for a customer who has a housing loan previously is about 36%. The odds of a customer without a housing loan, that's a decrease of 64%. And that's also highly significant. So this chart is useful to visualize the odds ratios for the most significant predictors. The blue bars represent factors that increase the odds of subscribing, and the green bars represent factors that decrease the odds. As we saw in the EDA, a previous campaign success, P outcome success, is the strongest predictor. It increases the odds of subscribing by almost 8%, 8 times. And contacting customers in March or September or July, as we can see, also significantly increases the odds. On the other hand, housing loan, we see that again, being an entrepreneur or having a blue-collar job like we saw in our EDA, significantly decreases the odds of subscribing. Here we have duration illustrated in another useful chart. We can see the effect illustrated, and we have our confidence interval too. But to sum everything up here, in objective 1, our interpretable model had an AUC of 0.896, which is excellent. The most powerful positive predictors here are duration, the month of March, and the previous outcome being a success. The most powerful negative predictors are housing. Yes, they have a housing loan, their job being an entrepreneur, and they were contacted through telephone. Overall, though, we noticed that this model has clear and actionable insights. Longer and more engaged conversations are really crucial. The previous success strongly predicts the future success, and customers with existing financial obligations, like housing loans, are less likely to subscribe.
And so moving on to our second objective, we want to do non-additive logistic regression. We want to compare different kind of models to see what's going on in our data. The goal is to maximize predictive performance on the test data. And so the baseline model we are going to be using is the simple logistic model that we have done in objective 1. We are going to combine with our simple model. We're going to iterate, and we are going to, our iteration is being justified by the EDA we've done. We're going to do LDA and QDA models. We will also do a simple non-parametric model, which is random forest. We will also do step AIC logistic regression, and this will refine the step AYC feature selection algorithm. And then we'll do 3 of cross-validation models, do logistic regression cross-validation, we'll do random forest cross-validation, and we are going to do lasso penalization regression cross-validation model. And in total, it will be 8 models that we're going to be looking at. Hopefully, we're going to find among these 8 models the one we are going to apply for test on the test data. And so we have drawn our models, 8 of them, and now this table is the result from our work. We can see here that we are looking at the threshold, we are looking at area under the curve, area under ROC curve. We are looking at sensitivity of the models. We are looking at the specificity, and then we are looking at positive values there, and we are also looking at negative values there. What we're going to be making use of in this matrix will be shown to you in the next slide. And so moving on, like we said before, we want to compare side by side our cross-validation models performance metrics. From the look of things, the cross-validation random forest performed better with a highest median there, as you can see. And the cross-validation lasso performed next, and the cross-validation logistic regression was the third one there. But we want to pay particular attention to the wider interquartile range for CV lasso, because this shows that it's more consistent, and is valuable for scenarios where we are looking for interpretability and stability, because it's wider. So we want to pay attention to that. But we will see that cross-validation logistic regression is not really doing well there, because it has a lower median there, and then the wings of the box plot is lower. So that means it's hinting at variability there, or is sensitivity to certain data split. So, but we want to pay attention to cross-validation lasso. And well, we'll also be paying attention to rainforest as well. So this is great insight from this plot. And so the interpretable models that we have run, we want to compare side by side top predictors. As for logistic regression, the first 3 best predictor there is previous outcome success, and then is duration of call, and then the month of September within the sub-variables in the month variable. And as for random forest, it agrees with logistic regression, saying that previous outcome success is the topmost predictor there, and also the second one of duration. It agrees with logistic regression, but it disagrees with logistic regression in choosing the third one, because it chose payday. So we want to pay attention to that as we are moving on, showing you the third comparison of interpretable models. So the top 3 of lasso model cross-validation is also agree with the previous 2 models, choosing previous outcome success, but it's showing that month of March and month of September particularly is choosing the months variable there, not recognizing duration of call, and it's not recognizing the payday, and it's also not recognizing what logistic regression I've identified before. So yes, this is not surprising, because the internal algorithm of these models work differently. But we know from the outcome of these interpretable models we've shared with you that previous outcome success is very, very important. It's the strongest of all these predictors. And so we will proceed to show you more metrics from these non-additive models that we run. And so here we want to compare the the trained the model that we already have on the test data. We want to see their performance on the test data because that's actually what we needed to put it into production. And it looks like STEP AIC logistic regression model performed better and with area under the curve or area under ROC curve of 88.6% and trailing by LDA of 89.89%. And this indicates that they are very good in discriminating values within the model. Though STEP AIC logistic regression model also achieved a higher sensitivity score, like my teammate said earlier on, we are not particularly paying attention to accuracy. We are paying attention to sensitivity and specificity because our data is in balance. So when we look at this, we know that STEP AIC balanced this very, very well because it has a highest sensitivity score there of 89.9% and the highest of net positive value of 96.2%. So which makes it particularly effective in identifying true positive. We will not waste our money when we are trying to reach out to our subscriber. And also the QDA there performed worse of all of these on the test data. But we know that there are the first model that we look at, the simple logistic regression and the complex logistic regression. They also have values of area under ROC curve above 88%. And so it shows that day two is balancing sensitivity and specificity. But the one that we want to put our eyes on, that we want to keep in view, based on the metrics we have here, is the STEP AIC logistic regression. So we're going to be showing you along the line how we meant that seriously, that paying attention to STEP AIC logistic regression is a way to go. So looking at the curve itself, the ROC curve for these models that we have, as we've said, we know that STEP AIC have AUC scores at 89.4%, and it's been followed by cross-validation lasso of 89.2%. So both of these models show strong performance. It suggests that they had good feature selection and they regularized and generalized meaningfully well because they have good predictive power. And so we want to pay attention to them. And though cross-validation random forest shows superior AEC but we want to see that only when we have high-stake scenarios where classification accuracy is critical. But in this case, we are not looking at accuracy only. We are looking at sensitivity. We are also looking at specificity. So that's why we are confident. We know that STEP AIC is where we want to go. So because both STEP AIC and cross-validation lasso, they offer competitive performance because they balanced sensitivity and specificity. They were not looking at only accuracy. So we know that they added extra layer of interpretability and feature efficiency. So we're going to be showing you that, like I said before, shortly, why we believe STEP AIC is the way to go. So as we have said, we are going to test run STEP AIC with our business data and see how well it will bring in money for us. And so we know actively that we have 100,000 active subscribers, and we know that every month we have 5% churn rate. And we know that averagely we make $50 on each of our customers. And we know that our cost per customer to reach out to them is $10 per user. And so with our model sensitivity of 89.9% on the performance on the test data and the model specificity of 78.1%, let us see the numbers, how we believe that STEP AIC logistic model is the way to go. So So after we have run numbers, projected outcome for 6 months, we run this number on the churn rate that we have shown you before of 5% on 100,000, that's 5,000. And so if you apply a true positive number, which is 89.9% on that number, it will give us 4,495 customers. And then we know previously that our previous campaign, the outcome of success is about, success rate is about 55%. So we approximated that to 60%. And so if you apply 60% to the 4,495 number we already get earlier, we are going to get a retained number of 2,697 customers. And so if you multiply our monthly revenue per customer on that number, we will get 134,850 because they subscribe. We are going to surely make that money on them. And so, but the cost to reach out to them is to reach out to the entire number. So the entire number is 4,495. And so if you multiply that with $10 per user, it's amounting to 44,950. So our monthly intake, extra money intake, the impact we believe Step AI Seal will have on our business is 89,900. If you look at that cumulatively in 6 months time, it will be 539,400. Isn't that great? Just on 5,000 customer alone. So if we can increase our churn rate to about 20 or 30%, this number will be going into millions. So in the little box on the right there is the ROI analysis. The total cost we are going to be running to deploy, do this pilot program for this model will be 269,700. That is if you multiply 44,950 by 6. And if you multiply $89,900 by 6, you're going to get 809,100. So if you deduct the total cost from the total revenue, you are still going to arrive at the same amount of 539,400. So we believe that if we test run this model, we will be able to see that the impact of this model will be great on our business. So I will now call on Ika, my associate, to conclude this project, and we can wrap things up quickly.
All right, fantastic. Thank you, Samson. So yeah, just to wrap this up for objective one, interpretation, our interpretable logistic regression model clearly identified that subscription likelihood is strongly linked to longer call durations, prior campaign success, and the absence of a housing loan. This model had excellent performance with an AUC of 0.896. It maintained complete interpretability, and we got some key and critical business insights that it's important to have good customer engagement. There's a strong positive predictive value of previous experiences and previous investment on the part of the customers. For objective 2, which is our predictive model, we noticed that the cross-validated random forest model was really good. It had a area under the ROC score of 0.906, and that's our final choice for prediction. It had a really strong sensitivity PPV balance. I can model complex non-linear patterns that linear methods might mix. It has a robust approach that captures interaction effects without requiring any sort of manual specification. And we would be remiss if we didn't discuss the overall scope here and the limitations to our methods. And a lot of these really have to be considered from a practical perspective. So in terms of scope, the performance of our model could really shift significantly based off of different geographical regions, time periods, economic conditions, etc. This model is based on Portuguese bank data. Is it going to generalize to other markets or economic climates? Is it going to generalize to America? Maybe consumers here are more sophisticated. Maybe the market here is saturated. So all of that has to be considered from a practical perspective. In terms of duration, you don't know the duration pre-call, like we discussed earlier. So maybe it's better in the moment, but if you want to pre-select customers and change your strategy beforehand, you would have to make a model that factors out duration. And in terms of implementation, your model should be regularly retrained and updated for market conditions and consumer behavior. And we should also optimize the threshold selection based off of the specific costs of false positives versus false negatives in terms of the operational context of the bank. And for objective 3, which was something we wanted to do to really put this model into a practical business context, we deployed the stepwise AIC model, the stepwise AIC logistic model for churn prediction. We noticed that a 2% return on investment over 6 months, we preserved over $500,000 in revenue. And this projection really highlights the value of precisely targeted retention strategies that are powered by interpretable models. And we were really thrilled by that result as well. So thank you for your time. Samson and I are available to answer any questions or address any comments. Thank you again very much.
Thank you.